Hello all, welcome to Excel Academy. So today we are going to see the problem on 4-point DFT, right? So I told we would be looking at another problem on 4-point DFT. So this problem is somewhat a different kind of problem. So it is not a numerical problem. See, you can observe your x of n. So see here x of n is equal to cos n pi by 4, right? It is in terms of cos and your numerical is not given. So you are supposed to what? So you are supposed to find out what is the x of n. That too with respect to numbers, right? In the last problem, I have got a question wherein my x of n is equal to that is 0, 1, 2, 3 students. Yes, I have got it as 0, 1, 2, 3. But here it is in terms of cos n pi by 4. I want it in terms of like this, that is 0, 1, 2, 3. In this way, I want my resultant of x of n. So for that, what I have to do? So my very first step I have to do, I need to get like this. So this is 0, 1, 2, 3, just I have written the numbers, that's it. So for this particular, you get another result. But I am telling that I want my resultant x of n of this kind, right? Of this kind. So what I have to do is that I have to substitute the values of n over here, right? I have to substitute the values of n over here from 0, 1, 2, 3. Till 3 you are going to substitute, right? Yes. And then you're going to get the resultant. So this is what you're going to do if you get a problem of this kind, right? Yes, these are all simpler problems, but what is the matter is you have to know how you get the questions. That is what we are trying to do. We are trying to do all the questions that comes for an examination, and we know how is the subject, right? So for your basic signal processing and as DSP, you can study the examination questions without fail, and you can also study the different types of questions without fail. Why? Because see, in this particular topic, so in the basic signal processing, the particular topic, so we had basic operation on signal problems, right? So there was different kinds of problem, but whatever the methodology you follow, that is with respect to the operations, would be the same, right? The operation will be the same. So that is what is those kinds of subjects are like basic signal processing and yeah, DSP, wherein if you try different kind of problem, your method and the procedure will be the same, right? But for your control circuits and control, it is not like that. Like in a sense, it is a network. There are all kind of network. There are all kind of block diagram wherein you are going to work more and more problems to get into the resultant, because for each and every problem in the what I can say, the control system block diagram reduction rule problems. So you are not applying the same methodology. You are applying a that is different methodology for different problem. You are going to working on different basis, because you get different rules and regulations in particular problem, right? In the particular problem, you might get a block diagram in parallel, or you might get what I can say, the blocks in parallel, or you might get eliminating the minor feedback loop, or you might get shifting a takeoff point behind what I can say, the behind the block, or shifting the summation point behind the block, right? And there is no a certain set of procedure that you have to follow for those particular problems. So you're going to solve according to the problem how it is given. You're going to work on, if you want to shift a takeoff point behind the block, you're going to do that. Or first, if you want to what I can say, eliminate the blocks in parallel or blocks in series, or eliminate the minor feedback loop, you're going to do according to the given problem. And even in the and even in the case of what I can say, the circuits also, in the case of circuits, it is like the procedure is the same, but the numericals are different. That is in the sense we are now doing with respect to mesh analysis problem or loop analysis problem, wherein if you what I can say, try to you will apply the same process of what I can say, the KVL, but the problem might be somewhat complex, wherein you are going to simplify the problem and do it. But in this kind of basic signal processing and this DSP, so the questions might be different, but same process you are going to apply without fail. But you are going to do some simplifications over here. Simplifications in the sense, if the problem is not given in a manner that you require, so you're going to do what I can say, simplify and get the resultant, that is get the resultant, and then you're going to start solving according to the procedure. So therefore these subjects are not that difficult for you students. So you feel that it is difficult, but it is not. The difficult subject is circuits and controls only, because you don't know what kind of problem you get, and you don't know what I can say, how to solve. Yes, yes. So in circuits also, you will apply the same KVL itself, but what is that going to happen there? So you are going to, there will be some different hurdles that come within you. That is, you have to take I is equal to I1 minus I2, or that is two mesh resistance between the two meshes, so and so it comes. You don't follow the same procedure, right? The procedure somewhat it will change there, you can observe. You will apply the KVL equations only, but you have to apply more and more procedures inside the KVL only. KVL, you don't apply KVL directly and get the resultant. You have to do so and so things for KVL, right? If there is any current that you what I can say if there is any what I can say, the current that you identify, so that current you're going to substitute in that equation, and you're going to do so and so things, right? You're going to do so and so things. But what is that going to happen in the case of what I can say, this subject is DSPS? So you have a question, that's it. Your questions will be different, but whatever the procedure you do, it will be the same process, and there will be no change in the process. So that is why this subject is really easier, and I'm trying to solve different questions from this particular each and every topic, so that you would get to know easily. And I'm working on only examination students. For examination, what kind of question he will give, and from that only I'm going to select different questions and do for you, right? Why I discussed about circuit and controls and basic signal processing over here is because to make you understand how this subject is than that particular subject, right? Circuit and control is only more difficult subject. You have to work more and more circuit, more and more problems. But here, if you understand the procedure, you are supposed to what, just one thing I'll tell you. For circuit and control, you have to work on more and more circuits, more and more networks, and more block diagrams and all. But here, if you just understand the procedure, if you just understand the procedure, you can do it for any type of problem that comes, right? That is what is the basic agenda. You have to see what are the types of questions that is present, and you need to understand a simplification for that particular. See, the simplification for this particular is, you are going to apply the values of n, you are going to get the resultant, and then resultant like this, and then you're going to start applying the 4-point DFT procedure, right? Yes, like that you're going to understand till the simplification part. If you see different types of problems, if you see what to do for that problem to get a resultant like this, so if you understand until that, and if you really know what is the procedure that you have to do, then you can do it easily, right? These are all procedure oriented subjects. They are not that much difficult, right? Yes, so you're going to work it on. I'm going to tell you how. So see, here you have to first four samples of x of n. You're going to find first four samples of x of n can be obtained by putting n is equal to, that is 0, 1, 2 and 3, right? Yes. So when you apply 0, 1, 2 and 3, that is equal to, see, cos of 0 is equal to 1, right? Cos 0 is equal to 1. Why it is 0? You have n pi by 4, right? You have n pi by 4. If you apply n is equal to 0, then this whole thing, if you multiply 0 with pi by 4, it's 0. That is what is we have written over here, which you will it as 1. Now this is cos of 1 pi by 4. That is for n you have substituted 1, and if you substitute this in calculator, you get the resultant as 0.707. Right? Yes. And here it is cos 2 pi by 4. So why 2 pi by 4? N is equal to 2. If you substitute 2 pi by 4, you are going to get it as 0. How? This can be done directly. 2 ones are 2 twos are. Cos pi by 2 is nothing but my cos 90. Cos 90 is 0. What is sin 90? Sin 90 is 1. Sin 0 is 0. Cos 90 is 0 and cos 0 is 1. Right? It's opposite. Yes, and then this is 3 pi by 4. What is 3 pi by 4 is minus 0.707. You're going to substitute all this in calculator, and then you're going to get the resultant. So I got my resultant as what? 1, 0.707, 0 minus 0.707. Let me write that. So it is 1, 0.707. Just a minute, students. I'm so sorry. Please do adjust. I'm so sorry. Yes. So it is 0.707, and it is what I can say my 0, and it is minus 0.707, right? Yes. So this is what is the resultant you are getting. So if you understand till this, so if you take this problem, if you understand till this, and if you know the procedure solving of 4-point DFT, then you can easily do it, right? You just have to only understand the procedure, how does it goes on, and you need to make sure that you're going to see the different kind of problem for this particular. So because this problem is not numerical oriented, you did not get this particular. Just a minute, I'll take another color. Yes, you did not get this directly, right? You did not get this directly. You have to substitute the value of n to get this directly. If you understand that particular part, and if you know the procedure for 4-point DFT, then you can do it easily. So that is why I told you these are procedure oriented, and you need to understand the procedure well, how does it goes on, and for each and every problem you are going to use the same procedure, but the values will change and you get the resultant as different. That's all. So that is why I'm telling you, I'm comparing with the circuits and control as well as this, because I'm going to make this subject really easier, and I'm going to help you crack your examination, and I'm also working for circuits and control also to make it easier. So please do um, like, share and subscribe to get all these facilities, avail these facilities for free, because many people I see that they, if they don't understand anything, they opt for one word that's called as tutorial, but it is not that. See, we are providing all these facilities for free, that too in a clean and neat manner. So please do avail this without fail. Instead of spending your money, you can easily watch these videos and you can get what I can say, the facilities and benefits, right? So please do try to subscribe and get all these benefits, right? Yes. So now let me what I can say, see the DFT of the sequence is given by. So that is, we got this result, and now let me start the DFT of the sequence. So you know what is 4-point DFT, that we have already discussed in yesterday's class. See, I'll write this and I'll tell you now. See, this is 4-point DFT, that is minus j, and what I can say, minus 1 and j, and it is minus 1, 1, minus 1, and it is what I can say, the j, and this is minus 1 and minus j, and that is here it is what I can say, my 1, that is 0.707. So that is 0 and minus 0.707. So this is what I can say you have to apply, right? See, the same thing you applied, right? But here it was 1, 0, 1, 2, 3, right? The same thing you applied, right? If you do solve this, you get the if you do solve this, you are going to get the resultant as, that is, and like the resultant. So that is 1. That is 1 minus what I can say, the j, what I can say, 1.414. You have to solve it. How to solve it is, you are going to take this whole thing and you are going to multiply it with this. That is 1 into 1, and that is this is 1 into 0.707, and this is 1 into 0, and this is 1, this is plus 1 minus 0.707. How do you do this is, I'll write it on the top, okay? Yeah, so I'll write the resultant first. So this is 1 and 1, and this is 1 plus j, this is 1 plus j, what I can say, that is here for 4 of what is that, what I can say, 1.414. Just a minute, it is what I can say, the 1.414. Just a minute. Yeah. So it is 1 and 1 plus what I can say, j, just a minute, j 1.414, right? This is what is you get the resultant. How do you get the resultant is you are going to write like this, that is 1 into, that is 1 into 1, which is 1 into 1, that is what I can say, plus, because there is no minus over here, it is always 1, so positive, so that is why I am going to taking 1 into 0.707. I'm going to write only one upward one, and you're going to do for all other three, right? This is 1 into 0, which is you can directly write it as 0, and it is plus, so that is 1 minus 0.707. Now this is 1 into minus 0.707, right? So like this you are going to do. This is what is for this one and this thing. So for this also you are going to this whole thing. Then next step is this whole thing you are going to multiply with this, and this whole thing. The third line you are going to multiply with this, and the fourth one you are going to multiply this, and you are going to write like this, and you are going to add, and you are going to get the resultant. Add or subtract according to the given. So see, here it is 1, but here it is what? It is minus j into 0.707. It is not plus, it is according to that you get. If you get minus or plus over there, according to that you are going to, what I can say, do it, right? Yes. So here you got minus j, so it is not plus, it is subtraction. So that minus j into 0.707, it is once again what I can say, plus 0, or you can write it minus 0. It is, yes, minus 0, because it is minus 1 into 0 is minus 0. So let me take it as minus 0, and it is, what is that? It is what I can say, plus j into minus 0.707, right? Like that you're going to do for all the other two. So that is you're going to do for this as well as this, and you're going to you're going to do add or subtract according to the thing that you get, and you're going to get this resultant. We have already done this in what I can say, the problem number 1. So I guess you have to watch the problem number 1 to what I can say, do see this problem number 2, right? So this is what is for today's lecture, and please do make sure that you like, share and subscribe, and if you really like our videos, please do share it to others, so that it will be helpful for others. And this is really for free, and you don't need to spend any money by going to any other teacher and asking them to teach the subject, right? It is really for free, so please do avail this facility without fear. And please do, for that you have to subscribe and watch my videos, and I'm going to help you for your exams till the end. And please do make sure that you just watch my videos, and give a like, and please do press the bell icon to get, what I can say, to all the facility, to avail this facility, and you get updates instantly on wherever you are. And this is what is I was about to tell you. And one last thing I'll tell you, don't go into extend that circuits and control is really difficult. No, if you understand the concept, it is easier. But why I compared this to you is because there you have to work more and more, but I just told you only one thing. There you have to work more and more problems, right? You have to work it on more and more problems in circuit and controls. But what is that going to happen in the case of what I can say, DSP? If you work 2 to 3 problems, you can solve all the other problems without fail, right? That is what I told you. If you understand the procedure here, you can apply the same procedure for all the other problems, and you can easily gain the result. And that is why I am telling you that for that you have to work more and more, but here you have to understand the procedure clearly for the subject, and do solve the problem, and understand the question first, and know how to simplify the question and get this resultant, and then move on. That is what you are going to know, right? And this is what is I wanted to tell you. And in the next session, that is I'll provide a session today itself or one session tomorrow on the control, on the circuits and controls, and we are going to do one problem on complex problems on nodal analysis. And please do what I can say and please do what I can say, watch my videos without fail, and thank you.